This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com.
Alright, finally, the one other. Now this is one I am not going to give you a sheet on, I'm afraid, because I don't think you should need one. And to go through a sheet, if we do an example, it takes ages. It's something you can't do a bit of. I want to talk for a few minutes, but can you find your formula sheets? Because the last one is regression. And I'm sorry, but whether you were here or not, when you were here, we did go through a full example. If you weren't, you should really have seen it in the study text, or if not at school. But it is really just sticking figures in a formula, and so I just want to make sure you're clear what we're doing and why and what the symbols mean, and you with me? All we're doing, it's useful for forecasting. For instance, that equation I gave you earlier, when I said the trend was 12,000 plus 30 times t or something. You remember? Just let me have it in front of me. I said the sales was 12,000 plus 30 times t. Well, two things. You should all be happy that if you put all the sales on a graph, any equation of that form would be a straight line. You all agree? And if you were trying to get that equation yourself, well, it's always an equation like that where something equals something plus something times something, if you understand me. Our problem here is getting the 12,000, getting the 30. Those of you here remember, I had an example with a whole list of figures, month 1 was this, month 2 was this, or whatever. And the whole idea is to come up with an equation like that, to get those figures. The equation you're looking for, they give you on the formula sheet. It's always of the form A plus bx, where y and x could be anything. It could be sales, where we know the time, the month. Yep. It could be cost, when we know the number of units. But whatever it is, you're trying to find A and B. Is it 12,000 plus 30t? Or, is it 10,000 plus 40t? I think you all know what I'm getting at. Well, I'm not going to talk long. I really shouldn't need, but a couple of things. One thing could just be important. That always is an equation relating two things together, like sales and month number. But it could be important in the exam. You choose the right one to be y and the right one to be x. The wording, but then I'll just check you understand me. Y is the one that depends on the other. And so to make clear you understand what I mean, and then I'll just check you with one or two. That one that we had earlier where the equation sales was equal to something plus something times the month. Surely if the sales and the months are related, would it not be logical the sales depends on the month? You with me? Depending on which month we are, we sell more or we sell less. I think fairly obviously, the month we're in doesn't depend on how many we're selling. Yeah? And so, the equation, sales would be y, because it depends on the month, which would be x. Okay? Alright, now they won't be nasty, but just let me check with two that you have understood me. Suppose I gave you one where I gave you the production in units and the total cost in dollars. Which depends on the other? Which would be Y and which would be X? Say again?
Costs depend on...
Yeah, so which one would be Y?
Costs.
Yeah. Yeah. You know, ask yourself, which one depends on the other one? Surely the total cost is what depends on what you produce. Your production doesn't depend on how much you've spent, you know? And so, Y would be the total cost. It depends on X, the number produced. Alright? Let me ask you one last one. The height of flowers the amount of... Are you happy with the word fertiliser? Alright, she won't use that word then. Let's think of another word. The amount of liquid food, liquid plant food. You can't argue about that. You might not buy plant food, but you know you can buy plant food to feed your flowers.
No.
You've got me. So I'm saying, yeah, those two stand to be related. If you're trying to find an equation, how high your flowers are, how much plant food you've fed them, which would be X, which would be Y?
First one, Y.
Yes, surely, if there's any link at all, it's the height of the flowers would depend on the amount you fed them. Alright? So that was a bit extreme, but anyway, I think you've got the idea. Secondly, though, where the numbers come is, of course, I said before, what you're trying to find is the 12,030, the A and the B. You've got the formulae, well that's the bit, I'm not going to waste time doing all those numbers, but remember what they mean. What does sigma mean, please? Which is, it's the sum of. So sigma, Y for instance, is simply the total of the Y's. Sigma, XY, for example, is the total of all the X times Y's. You with me? You multiply X times Y each time, you add them up. What does N equal? Number of? Alright, number of numbers, yeah. Always when you're doing this, a full example, we might have looked at, 8 months. How did we produce, what did we spend next month? 8 times. Well, N is the number of sets of observations. Pairs of observations. And so, that's all we need really for A and B in the formula. That here you've got to in fact do B first. You work out B sticking the figures in. Once you've got B, use the other formula to work out A. Alright? Finally, and completely separately really, you can do that for any set of numbers you were given. But there's only any sense in doing it if basically it's more or less a straight line. If things aren't a straight line, then coming up with some equation is really a waste of time. Yep? And so, although numbers on this are extremely unlikely, she could mention R. R is the correlation coefficient. And just 3 things here. There is a formula. I'm not saying she can't ask you to put the numbers in, but that's unlikely. But it's the coefficient of correlation. What it does, it measures how linear the observations are. Are they all in a straight line or aren't they? Are you understanding me? Well, surely, this you must remember. The value of R is always within what limits, please? Nearly. Yes, yeah. It's always between +1 and -1. Always. And finally be able to interpret them. If it's +1, it is perfectly linear. It's perfect positive linearity. It means that the two things go up together, produce more cost. It's an exact straight line. They both go up together, yeah? If it's -1, it's perfect negative correlation. Or perfect negative linearity. And that would be this sort of situation. Whereas one goes up, the other goes down, but in a straight line. Clear? You know, maybe it's how much money you spend on medicine and how ill you are. The more you spend, the less ill. Perhaps that doesn't make sense, but you know what I'm trying to say. Those would be perfect. The further away from +or -1, the less perfect it is. I'm not going to write, but if it was 0, we would say there was absolutely no link at all. Okay?